In this word problem, we're looking at a exponential function here. We can see that we're increasing by a rate. So I've got to think of y equals c a to the x power. And in this one, she starts her first week by doing a 5-mile run. So that's my initial amount. My c is 5. She increases her run by a length of 25% of her distance from the previous week. So the 25% is a rate that we convert to a decimal, 0.25, when you move the decimal 2 places to the left. And remember, the relationship between A and R, when it's increasing, is 1 plus R. If it were decreasing by 25%, then it would be 1 minus R, and she's not doing very well in her racing here. So for ours, we add 1 to the 0.25 and get 1.25. Remember, that number's got to be bigger than 1 if you're an increasing function. So our formula is going to be D equals our C value times our A, 1.25, raised to the W, our time unit, weeks. So according to this model, algebraically determine the week. So I'm plugging in for the distance here that she will run 20 miles. So the 20 goes on the left side as my output, and then solve for W. So again, divide off by 5. Rewrite it as a logarithm. And then that's equal to the power. So with your calculator, again, if you don't have the button on your calculator like this one doesn't, then you're going to have to do change base. You do log 4 divided by log 1.25. You could also use the natural log button, top and bottom, doesn't matter. So it looks like we're in week 6. So even if it had been like 6.9, we'd still call it in week 6. So in week 6. So in week 6, she runs 20 miles. So for the U-try-its, a lot of these are exactly what we've been doing. Solve for the exponential, divide off by the number in front. So I have 2 equals 1.09 raised to the x power. So this is an exponential. We get rid of it by using the word log. The base comes down. Okay, there's my exact answer. Now the decimal approximation. Again, log 2 divided by log 1.09. And we're rounding to 3, so the 8.043 would be all that I'd write in. Letter C, divide off by 200. So 100 divided by 200 is a half. You have the exponent by itself, or the exponential, so rewrite it as a logarithm. Log base 1/3 of 1/2 equals x. So once you have the x by itself, that's the exact answer. Now go to your calculator and do the same. So I'm going to do log 1/2 divided by log 1/3. Come up with 0.63, and again, to 3 decimals, it'll be to the 631. Round it up. All right. Letter D, divide both sides by 18. So we get 2 equals 3 to the x. Log base 3 of 2 equals x. Right. Again, split it up. Log 2, top number goes on top, divided by base goes to the bottom. Right. I get again 0.631. And then let's see, here again it's hooked by multiplication, divide it off. So 1/2 equals 0.6 raised to the x, or 0.5 either way. Log base 0.6 of 0.5 equals x. So with the calculator, log 0.5 divide log, oops, got to have it as log, not natural log here, 0.6. So about 1.3569, but that 6 is going to bump up to 7, so 1.357. The word problem, they give you the equation in y equals ca to the x form. Remember, the number in front is your initial amount. So when they're asking what is the original or initial amount of epinephrine in the blood system, it's 0.25 and then milligrams. I mean, you only have 2 options. It's either milligrams or minutes, and if it's an amount, it's going to be in milligrams. How long will it take to half the epinephrine in the blood system? So if you originally start with 0.25 and you want half left in your system, multiply it by 1/2 and you're going to get 0.125 milligrams. But we want to know how much time is it going to take. So the 0.125 gets plugged into the left side of the equation, and you're solving for t. Okay, so we're not doing a guessing test here. We're actually solving. Divide by 0.25 to both sides. All right, and if you actually do that division, it will come up as 0.5. All right, to get rid of the logarithm, or I'm sorry, to get rid of the exponent, you take a logarithm. So do log base of the exponent 0.788 of 0.5 equals t. All right. If you need to, split the log up using your change of base formula, log 0.5 divided by log 0.788. All right. So we have 2.909, and they want it rounded, I think, to the nearest minute. So in that case, it's going to round up to about 3 minutes.